Good evening, my name is Tejas Ahuja and this is my digital assignment for image processing. Here I am doing image smoothing using DCT transformation. So let's start. So here is the code for image smoothing using DC2 transformation. So I have imported CV2 library and then matplot library and then numpy. Then I have taken Lina image and 0 marks grayscale. And then what I have done is that I have taken the DCT transformation of this image. And then now I have shifted the transformed image. Now then what we have done is that we have taken the center value of the row and the column, and then this is the center value and it's stored in center. Now what exactly we are doing is that we are calculating the mask area, and then for that which is actually just the square distance between the pixel values and the center, and if it is greater than r square, then we are just simply substituting this value as 0. So after preparing the mask, now I have just multiplied this mask with the DCT shift. Now then as soon as the mask has been prepared and it has been stored into the F shift, then what we have done is that to get the image back after, because it was done by DCT transformation, we have used inverse DCT transformation function to get the image back from the DCT transformed image. So what we have done is that I have plotted total of 4 images. One is input image, then second is DCT of the image, direct cosine transformation of this image, then DCT plus mask of this image, and then the exact image after the inverse of the transformation. So let me run this code. So let's check. You can clearly see that this is the input image and this is the DCT graph of this image, and you can see that after the inverse transformation of DCT has been taken, you can see that image has been smoothened, noise has been removed, and then you can clearly see the blurriness of this image. Now let me give some hands-on experience. Now let's change this value of r equal to 15. As soon as I change this value to a smaller value, let's say 10, then you can find that this image has become a more blurry than previous one. So you will find that as soon as I will increase the value of r, let's take it 50. So now you can see a proper image with little bit less blurriness and then a less smoothened image. So what we can conclude is that as soon as I reduce the value of r, the blurriness and the smoothing of the image intensifies, because this r actually determines which mask value will be converted into 0. So this is the actual image smoothing through this code. Now let me move and forward to image sharpening. So this is the code for image sharpening. Similarly, in the similar way, we have taken these 3 libraries, and then image has been taken similar of Lina only, and then now this is the DCT transformation using cv2.dct function. Now as the image has been transformed using DCT transformation, these are the center values, center coordinates, and then similarly we have taken the square distance of each pixel value from the center, and then here if it is less than r square, then that value we are taking the mask as 0. Now similarly we are multiplying DCT shift with the mask as to generate the mask plus DCT value, and then finally what we are doing is that we are taking the inverse DCT transform of this mask. Now we get back our image. Now we need to plot the various graphs. So first input image has been plotted, then we will plot DCT2 image, and then we will plot DCT plus mask and then inverse of DCT. So these 4 we will plot. Now let me show you the output. So you can find that clearly it is visible that the edges has been clearly detected. So we have sharpened the image and edges are clearly being seen and found, and rest of the background has been turned to black. So this image has been clearly sharpened. Now let's change and play with the values of r. Let me take the value of r as something less 8. So here you will find that it has not got edges are not much clearly visible. So as soon as I will increase the value of R, you will get a more sharpened image which will clearly distinguish between edges. So let me take the value as 15. So you can find it that this is the result, and then this value you can clearly see that edges are clearly visible as compared to the previous one, and then rest of the background is black, which is not compliant with the edges. So this image has been perfectly sharpened. Similarly, as I will increase the value from lower to high, you will clearly find out the difference of the edges. So here this is clearly explains all the code properly for the image smoothing as well as image sharpening using DCT transformation. So this has been done by using DCT transformation. Thank you.